Hello everyone. Today we'll be solving this question right here. So the question says, the diagram in the answer space shows a quadrilateral EFGH drawn on a square grid. Draw the image of the quadrilateral EFGH under the reflection on the straight line PQ. So this question right here is asking us to draw a reflection on the axis of reflection, which is PQ.
There are certain features of reflections. The object and the image are on opposite sides of the axis of reflection. The object and its image have the same perpendicular distance from the axis of reflection. The shape and size of the image is the same as the object, but the orientation is reversed. The image of a point on the axis of reflection is the point itself.
There are also certain properties of an image of a reflection. Firstly, the image is the same shape and size as the object. Secondly, the image has different orientations, inverted sides, and forms mirror images with one another.
Because at the same perpendicular distance from the edges of reflection, this means that the distance from the line PQ to each point is the same. In order to draw the reflected image, we must count the perpendicular distance between the points and the edges of reflection. First, the perpendicular distance between point F and the line PQ is 1, 2, 3, 4, 5 units. Secondly, we will count the perpendicular distance for point G. 1, 2 units. The total distance is 2 units. Next, the perpendicular distance between point H and the edges of reflection is 1, 2 units. Finally, the perpendicular distance for point E is 1, 2, 3, 4, 5, 6 units. Now, we will invert the points to draw the reflected image by using the perpendicular distance between the points and the edges of reflection. Find the perpendicular distance from point F is 5 units. Just need to trace it over the answer space. 1, 2, 3, 4, 5 units. After that, the perpendicular distance for point G is 1, 2, 2 units. Then, the perpendicular distance of point H is 1, 2, 2 units. Last but not least, the point E's perpendicular distance is 1, 2, 3, 4, 5, 6 units. Before we reach the final answer, we need to connect each point with straight lines in order to form the reflected image.
From the image that we just drew, we can see that it fits all four features of a reflection. First, the object and the image are on the opposite sides of the axis of reflection. Then, the object and its image have the same perpendicular distance from the axis of reflection. The shape and size of the image is the same as the object, but the orientation is reversed. And the image of a point on the axis of reflection is the point itself.
The drawing also fits all the properties of an image of a reflection. We can see that the image is the same shape and size as the object. It also has different orientations, inverted sides, and forms mirror images with one another.
Because it has the same features and properties of a reflection, this means that this is the answer that we are looking for.
For question number 2, we are asked to simplify in bracket a plus b times in bracket a minus b minus a times in bracket a minus 2b. To ease our calculation, we should simplify it one by one. The first part is to simplify in bracket a plus b times in bracket a minus b. To simplify it, we should do an expansion. When doing expansion on two algebraic expression in two brackets, every term in the first bracket must be multiplied with every term in the second bracket. So, positive a times positive a, we get positive a squared. Positive a times negative b with negative ab. And positive b times positive a, we get positive ab. And positive b times negative b, we get negative b squared. After that, we could solve negative ab plus ab, which equals to 0. Then we are left with the answer a squared minus b squared.
Next, we need to expand a in bracket a negative 2b by multiply a with the terms in the bracket. A multiply a will be a squared, while a multiply negative 2b will be negative 2ab. The answer will be a squared negative 2ab.
So now that we got both equations simplified, we need to solve it just like what the question wants us to do in the first place. So a square minus b square minus a square minus with 2ab. So a square minus a square will become 0. So we are left with negative b square minus 2ab.
After we get this answer, we can actually factorize it as well. So there are two b's here, so we should factorize it and put negative b negative 2a in the bracket. It's because b times with negative b, you will get negative b squared, and b times with negative 2a will get negative 2ab. So this is the final answer for this question.